Hello everyone, my name is Keshav and this is my Lab 2's presentation video. The experiment included dropping an object from rest and using momentum's principle to predict and compare the motion of the system. I used a paper ball in this experiment. The first case was to neglect drag, while the second case is to take drag in consideration. Tracker was used to interpret the data while grow script was used to write the code. According to the momentum's principle, a net force on a system will change the momentum of the system. In Model 1, the net force on the ball is a gravitational force. The net force in Model 2 is the difference between gravitational force and drag force in the downward direction. The effect of turbulent drag, which is the drag which acts on the ball, uh, is, 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 is in a direction which is opposite to the direction of the object's motion and whose magnitude is proportional to the square of the object's speed. Since the net force is not constant, we assume that V average is equal to is somewhat approximately equal to the final velocity. Using this, we get the position update formula. Rf is equal to Ri plus Vf delta t. The video was recorded in an isolated room with no fan or wind to avoid any unnecessary reaction on the ball. Camera was placed approximately 2 meters away. The ball was dropped from as high as possible to the floor. The paper ball is a system, while the earth and the air are the surroundings. The next two slides are the glue scripts code with links provided in the slides. This is the motion of the ball. This is a graph of position versus time, while this is a graph of velocity versus time. This model is the first model where there was no drag. This model is the model when the drag is considered. The blue line is a motion of the drag, while the orange line is the direction of the force. This is position versus time graph, while this is velocity versus time graph. The red line is the predicted motion of the paper ball when there is no drag, while the blue line is the motion when drag is considered. The black line is the experimental data. It can be seen that the black line is similar to the blue line. The paper ball approaches terminal velocity near the end. The model, the model with drag also predicts that. The model without drag predicts constant acceleration, therefore, the graph between velocity and time is a straight line. The model with drag does not have a constant velocity. It begins to plateau, which means that after that point, the velocity of the ball is not changing with change in time and it has reached terminal velocity. If this graph is extrapolated, it predicts that the ball will have a terminal velocity of minus 1.81 meter per second, where minus means where minus represents the downward direction. If the ball had an initial velocity, the paper would have plateaued quicker, therefore it would have reached the terminal velocity quicker. This can be seen through the graph also. Thank you.